Welcome to Internet Quality Academy. The channel is for the quality control engineer, civil engineer, and the site engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topic that is related to reinforcement. Whenever the reinforcement is coming to our site or the projects, we need to perform the rolling margin test. That means what is the unit weight we are getting as per the requirement that we need to show, because it is a very important. So today we are going to discuss each and everything about the rolling margin, what is rolling margin, why it is important, and how to perform, and what is the acceptable limits, and what is the relevant I scored for that one. Today I will discuss each and everything. So stay tuned until the end to get the full information about the rolling margin of reinforcement steel. And if you are new on my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject. That is, first, what is rolling margin? That rolling margin is the difference between the actual weight of steel reinforcement and its theoretical weight based on its normal diameter of the length. So now we need to find out the what is the theoretical weight of the bar. We are getting 8 or 10 or 12 or 16, 20, 25, 32 is like this. Now we need to find out first that what will be the theoretical, because whatever we are doing the design, we are calculating on the basis of the theoretical weight, not in the actual. Now, when this rebar is coming to the side, it is our duty to check that what is the unit weight, or in the running meter, how much the weight of the steel bar that we are receiving, and the difference between, or the percentage, that is called the rolling margin. Essentially, it represents the deviation in weight of the steel due to variation of the manufacturing process. Rolling margin is expressed as a percentage. That means it is the difference between the theoretical weight and the actual weight, because we need to find out, or we need to think that whatever the design parameter that is satisfying whenever we are actually doing the work or doing the actual reinforcement work. That is why it is very much important to know the rolling margin of the reinforcement. So this is the rolling margin. Now it is why rolling margin is important. It is very much important to know. Then why we should know, or why we should perform the rolling margin test. First is the quality control. It helps in ensuring that the steel supplied is within the acceptable limit, ensuring the strength and the structural integrity. That already discussed. That is it, or the design weight and the theoretical weight, or the design weight and the actual weight, that should not deviate as specified limit in the ISO. I'll discuss later what is the specified limit that we need to verify in order to get the quality product or its strength and structural integrity of the project. Then cost efficiency. Inaccurate rolling margins can lead to excess uses of steel or underuses, which could affect the project cost. That because we are always purchasing in ton or in the kg, but if there is a difference in the diameter in the weight of the bar, then the reuse can be or underuse can be happen, and also it can impact on the project cost. Suppose we are purchasing 1 ton, but it is not exactly the 1 ton, but we are paying for the 1 ton and we're getting less. That is, it is the project cost is increasing. Then the safety. Maintaining rolling margins within acceptable limit ensure that the steel reinforcement can handle the loads it was designed for, contributing the structural safety. That is the main purpose of the rolling margin, because design has done as per the theoretical weight. Now we need to find out at the side that whatever the material we are using, that is as per the theoretical weight or the specified limit of the tolerance, that we need to verify and we need to confirm, so that in order to get the structural safety. And then compliances. It ensures that the steel reinforcement meets the standards set by the Indian standard codes, maintaining overall construction quality. So main things is that the structural integrity, quality control, safety, and the cost efficiency, that is very much important. That is why it is required to know what is the why rolling margin is important. The next part is theoretical weight. All we know that what is theoretical weight, because what is the mass per unit area. So mass per unit, that means in unit weight, it's one running meter. What is the mass? That is a theoretical weight. And where we can get one? That we can get in table 1 IS 1786 2008 in reaffirmed in 2018. In table 1 we will get the theoretical weight. So here it is mentioned, if it is a nominal size 4, cross sectional area 12.6, and mass per meter is 0.099 K9 kg. So in 1 meter of 4 mm diameter of bar, that will be is 12.6 is the running of square meter, and weight is a 0.099. Similarly, for the 10, it is cross sectional area 78.6 millimeter square, and the mass per running meter is 0.617. Now, whenever we are getting the steel at the site, we need to verify that this weight is as per the specified limit or not, because the design has calculating everything on that basis. Now we need to finalize, or we need to confirm that whatever the method we are using here, that is satisfying the criteria of the design parameter. So table 1 of IS 1786, it is describing what will be the cross sectional area, but we are commonly taking the d square by 162. It is commonly used to get the running meter area or the nominal mass. So but here it is in IS 1786, in table 1 it is given what is the cross sectional area and what is the mass. Next is, what is the rolling margin? How we can find out? See, actual weight of the steel, how we can find out? The actual weight of batch of steel bar is determined by weighing a specific length, normally of bars 1 meter. Whatever we did, whenever the material is coming, we cut in one piece in three different bundles, so that there will be more accurate, and we can take the three samples and we can take the average. So what will be the trailing margin? That will actual weight minus the theoretical weight divided by theoretical weight. Suppose in say in 32 mm dia bar, we are getting average of three sample is 6.25 kg. Now, what will be the rolling margin? 6.31. See, here it is 32 mm, 6.31. So that is the theoretical weight, 6.31 for 32 mm. So theoretical weight minus 6.24, sorry, it is 25. Sorry, it is 24. Suppose it is 24, we are getting 6.24 kg. Now, rolling margin, what will be the 6.31, the theoretical weight, minus 6.24, that is the actual weight, divided by the theoretical weight, is the 6.31 into 100. It is coming 1.1%. So, whenever the steel is coming to the side, take three samples of 1 meter for three different bundles or three different areas in order to get the more accurate average. So take the average of three sample and find out the rolling margin divided by theoretical weight minus the actual weight divided by theoretical weight into 100. That is a percentage. So the much where this is 3 bars, you can make it 6, 9. So the number of samples increase, the number of accuracy will be, the accuracy will be more. So this way we can find out the rolling margin of a steel. Now we are getting here 1.1%. So whether it can be accepted or not, that we need to find out now. How? It is also mentioned in the IS 1786. What will be the acceptable tolerance? That acceptable tolerance is given in the table 2 of IS 1786 2008. So what is it saying? That up to including 10 mm. So if it is a 10 mm, the batch should be plus minus 7%. Each batch or the individual sample, that is minus 8%, or individuals or by coils, if we are not discussing about the coils here, but if you're getting the coils, that is a plus minus 8%. Then over 10 and including 16, so 10 to 16 is plus minus 5 for batch, an individual sample is minus 6, and over 60 is plus minus 3%, and individual sample is minus 4. So see here is for individual sample, plus tolerance is not specified. A single sample taken from a batch as defined in 3.1 shall not be considered as individual sample. So one sample, is not considered a sample. So it is a minimum 3 sample. Not only in the steel, everywhere is the minimum sample is still. In the cube also, whatever the average of 3 sample we are getting, that is the one sample. The individual cube is not accepted. So here is saying a single sample taken from a batch is defined shall not be considered as an individual sample. For coils, batch tolerance is not specified. So here what is saying, over 16 is batch is plus minus 3%. So our is whatever we are getting, that is plus 1.1%, right? sorry, plus you are getting is minus 1.1%. So here it is saying the batch is plus minus 3%. That means it is within the acceptable limit. If it is not acceptable limit, we cannot accept that still. So whenever we are getting steel at the site, it is our primary duty to find out the rolling margin, and we need to find out whether it is in an acceptable limit or not, because it is defining the structural integrity of the structure, and it is the lifespan, it is the strength, the structure, in everything. So it is our primary duty to find out the nominal mass of individual sample, and we need to find out whether it is an acceptable limit or not. So these are the thing about the rolling margin of the reinforcement bar. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And if you're new, if you want to know anything about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.